Hi guys, this is the first of 10 tutorials for do-it-yourself kits, and this one is about power supplies and circuit breakers. This is tutorial A. So how do I start? So a power supply in industrial control systems is the same idea as the power supply on your laptop. So I've got, a laptop power supply. And what's going on in here is you're actually taking the wall, like AC, and turning it into DC. Yeah, see it says input, the wall, it's going to take 1.5 amps from the wall at 100 to 240, and then in the US we're just like 120, 110 volt AC input. And then it's outputting, in this case, 19.5 volts is what my laptop is. Sometimes it's 12 volts, sometimes, it's little volts. But in controls or industrial controls, we are almost exclusively doing 24 volt DC. So these are all different power supplies that put out DC. So this one you can see, it's a poles, puts out 3.8 amps of 24 volts DC. Here's a Meanwell. This one puts out 2.5 amps at 24 volts DC. This is an older Omron, and it takes, looks like 3.2 amps in and puts out 3.75 amps. Here, I'll use a screwdriver and actually point at this stuff. So there's the 3.5 amps. There's the 2.5 amps. Here's the 3 point whatever. Here's a Siemens. This one's kind of interesting because it's all coming up. It's all in and out of the top. You don't actually do anything with the bottom of this. On this one, these other ones, you come in on one side and you come out the other side. You come in from the top and then come out the bottom, or the other way around. Actually, all of these you actually are fed in from the bottom, and your output is on the top. No, that's not true. Not this one. Sorry, I'll show you. Okay, so this one, the DC's coming out the top, and the AC's coming in the bottom. This one, the AC's coming in the top, and out the bottom is your DC. This one's got your DC coming out the top like the first one, and your AC coming in the bottom. And then this one actually has both coming in and out of the top. So the left side is your AC, and the right side is your DC. And almost all of these actually do have, see that little PE with the little upside down Christmas tree is actually your ground. And most of these have a ground, but sometimes they don't. See that upside down Christmas tree again? That's that guy. And now here's the normal terminology, LN. So L is your live, which is your plus 120 volt from the wall. And then neutral is your N. Same thing going on here. See, they got the L again, and then this time they got an N. Same thing, upside down Christmas tree. So ground, neutral, live. This one doesn't have a ground. I'm not sure why. We can ask poles. Well, we can ask, I don't know, an electrical engineer, because I'm actually a chemical engineer. But yeah, so we got neutral and live. And same thing here. On the left side, we got, L1, L1, neutral, and the upside down Christmas tree, and PE. PE is I don't know, German for ground probably, so I don't know. We can ask our German friends about that. But the universal symbol for ground is that tree that's upside down. The actual tree part is actually supposed to be the ground. So that's supposed to actually represent the ground, and then the little line is you connecting to the ground. So that's kind of what that symbol means. And then all of these always sometimes it says V, but it's always there's always a plus and a minus. So you want yeah, you want to like differentiate between your DC common, which is your negative, or your plus 24 volt DC, which is your plus sign. So up there, plus symbol, minus symbol. Don't worry about that switch on the right side. We can discuss that in another video. Same thing up here. There's pluses and minuses. Sometimes there's just extra, like there's no difference between those. Like if you hook up the top or the bottom, plus or minus, like those are, the two pluses are connected to each other and the two minuses are connected to each other. So it doesn't change anything. Same thing here. There's just two terminals of each. L plus is your plus, M is your DC common. It's just different lettering because this one's German. Yeah, Siemens is awesome. But and then this one I'll just like throw in here because it was actually like we sent the wrong one. And this one, as you can see, the bottom L1, L2, that is not single phase. So this has the wrong AC type. It has the right DC coming out, 5 amps, 24 volt DC, but it doesn't have the right incoming. So if you see that L2, like that's not good. We don't have any L2 in what we're trying to do. And see that line with the solid line with the dotted line underneath it? That actually signifies DC. If you ever see that. Where's my cat? Okay, so that's power supplies, and like the whole idea here is that like it's the same thing as this black box. Is you want to do we want to do like our PLC, our HMI, our Ethernet switch, all that stuff is going to need 24 volt DC, so you want to have a power supply. And you know, same thing with like the way we plug it into the wall. We're literally going to hook this thing up to a circuit breaker and then hook that circuit breaker up to your power supply, and then, you know, produce the 24 volt DC so we can do everything else, because the only, you know, AC part of this is what's going to the wall and just coming into this thing, but it's actually coming into a C-type circuit breaker. This is gigantic, but let's go into the circuit breakers. So this is a 10 amp, the C10 tells you it's a 10 amp, and the C tells you it's a C trip curve. You have one of each of these because we gave you one C curve and one B curve, and they're both set for 5 amp is the rating for both of them. And here's some interesting things about these. See the green in power industry actually means that the breaker's off. That means safe. And actually red means like it's live and it's like dangerous. So sometimes you think red is like off, or like red is stop, you know, and actually red in this case means like you're totally live. And green means you're safe and you're actually not running power through here. And that is kind of the point of this, is like it's protection, but also it's unlike a fuse. You pay a little bit more money, but this thing will trip and you don't have to go find another fuse. You can just, you know, reset this after you fixed whatever, you know, whatever the current fault was. But yeah, the point of a circuit breaker is to, you know, protect from either overloading or short circuit. They all have inside of them, I should probably open this thing. I probably could. They all have thermal tripping units and magnetic tripping units, and the thermal tripping unit is for, you know, current overloading, and the magnetic tripping unit is for short circuit. And when I say trip curve like C or B, there are other ones, but like for this we just care about B and C. What I mean by a tripping curve is kind of like the x-axis is the multiple of the rated current that it actually trips at, and the trip curve, or sorry, the trip time is the y-axis. And so different types of circuit breakers have different trip curves because they're different types of loads that need to be able to either take, you know, a lot of surges, power surges, or, you know, inrush currents. And so they don't all need the same sensitivity. Sometimes you need to take a lot of inrush current, and sometimes, you know, you need to protect from any inrush current. So it just depends on the loads that you're protecting, whether you get a C or a B curve or the other curve. There's a D curve, there's a K curve. There's some more curves. But yeah, we care about C and B. And so C curve is for high surge, and it'll trip in, you know, 0.04 to 5 seconds, and it trips at 5 to 10 times the rated. So if this is, you know, this is rated for 10 amps, so it's gonna trip at, you know, 5 amps to 100 amps. And then the timing is, you know, up to 5 seconds. So it's going to take up to 5 seconds to do that. A B will take longer, but it trips at a lower multiple of the rated curve. So it actually trips at 3 to 5 times instead of 5 to 10, like the C. And it takes longer to trip. So it's meant for more like low surge, resistive loads, and C curve is meant for higher surge. And so we put, you know, the C curve on your on the power supply. Actually, no, we put the B curve on your power supply and the C curve on your on the bottom side of your power supply. I'll show you in the wiring diagram later. But yeah, that's the basic tutorial for power supplies and circuit breakers. They both have, you know, amperage ratings that they need. This one, you know, is the rating is 10 amps. Here, we can look at some stuff on here. This also has some other ratings on here, like it doesn't want to do more than 230 volts. And made in Romania. There's another one over here, and this one says C1, so I'm gonna assume it's a 1 amp that can take 230 to 400 volts. I don't know where we got that. Okay, well, anyway, so that's pretty much what I wanted to at least cover on these power supplies. I think the one you guys are getting is a Meanwell like this, but it's a larger size, so it's a 5 amp. And I will show you in the wiring diagrams how to turn those on, or how to wire those. Let's see if I can say enough times. Thank you.